Hello, Assalamu alaikum. So today we are going to start statistics for O levels. Let me present my screen. Okay, so let's start with the topic of statistics. I'm going to show you quickly the work we are going to do today. First objective is collecting, organizing, and displaying data, right? It is from Statistics O Levels 4024. So let's discuss the type of data we have, and what is data actually. Data is the collection of raw facts and figures. Raw facts and figures. So there are two types of data. Mainly we have qualitative data and quantitative data. When we discuss about the qualitative data, this is about the names, categories, data can be, for example, fruits, vegetables, and schools, number of students, by the names of the schools or the names, everything related to the names. Then we have quantitative data. Quantity is of two types, discrete and continuous. Number of students, for example, pens, tools, books, copies. These are the examples of discrete data, please. And this is those quantity or quantities. These are those quantities which can be counted. Countable quantities are discrete quantities, whereas measurable quantities in decimals, in the real numbers, known as continuous values or continuous data. For example, mass, time, temperature. Okay. Then the next part of this topic is organization of data, where you have to organize the data to understand. If you have raw facts or figures, when you organize them, then you will get to understand which type of the data you have and how can you check out its average, or you can do some analysis and you can interpret easily, right? So the frequency distribution is the way in which you can distribute or organize the data, well organized, to and for the analysis and for the comparison of the values, right? So let's discuss type of distribution table. This data table is without groups. These are the values. For example, we have dice and we draw this and we'll get the 1, 2, 3, 4, 5, 6. Maybe you will get, you draw the table like you draw a coin or a dice. Here it's the data for the dice. There are 6 values. Let's suppose you draw 100 times, and 1 will be 10 times, 2 5 times, 3 10 times, and up to so on. You can record those values in this form. This is called frequency distribution. Then data can be the group by data, where you can make the data into the classes. For example, in your school, there are thousands of students, and you will be understand when suppose all the students are in the ground. You will not be. It is not possible for you to check which student of which class, and if you divide them or organize them in the form of columns and rows, then you can easily recognize which class student is there in every row or column, right? So this is very important to organize the data for further analysis or understanding, for interpretation. And now it is presenting the data. Presenting the data is like when you draw the graph of the type of the diagram of the data. There are different types of diagrams we have in presenting the data. For example, we have bar chart. You may study in grade 6, 7. bar chart we have, pie chart, we work on the pie chart in circle, then histograms we have, then scatter diagram. This is very important for future business purposes. We organize data, we analyze, will check the positive and the negative correlation between the quantities, and we can decide to stand our business. Okay, let's start with the next one we had. So here we have a question. Table shows the number of patients at the emergency department of hospital on Monday morning 7 till 12. You can see we already had organized this data, the time given of the day 7 to 8, then 8 to 9, 9 to 10, 10 to 11, 11 to 12. So for 10 to 7 to 8 we have 3 patients, 8 to 9 we had 6 patients, and up to so on. Total patients are 45. This symbol shows summation or sum, and sum of f is 45. There are 45 students from 7 to 12. So we can answer this question. Choose a suitable simple symbol to use. Show this information by drawing a pictogram. This is very important. This is actually the presenting data we have. This is organized data. This is not a rough or raw facts. It's totally organized. It is understandable. From 7 to 8 we have 3 patients, 8 to 9 we have 6 patients, and up to so on. So how to draw a pictogram? Actually, you will use the pictures to represent this, and you have to make a key that is very important to represent each unit. For example, I had made it a small picture and it's showing 3 patients at a time. So for 7 to 8, let's see, 7 to 8, how many patients? 3 patients. I will just draw one picture. And if I want to have 8 to 9 patients, there are 6 patients, I will draw 2 pictures, and up to so on. I hope you got it. Then next, okay, copy and complete the sentence. Altogether, dash patients arrived at the hospital. We already counted. Altogether, 45 patients arrived at hospital. This period of 7 to 12, we have how many hours? This is 5 hours. In 5 hours. Next, we have another table. This data is actually not organized data, and you have to organize this data, right? So this is an example of organized data, right? And this data is not organized. You have to put this data into table form. See, it was organized, and we can easily check which number of people, how many number of people in the first part of the working time. Maybe you can say 7 to 8 we have 3 patients, but here we have data of the students, 40 students, they got marks out of 10 in a quiz of chemistry. So it's difficult to understand whose average is good, who was average student, who was topper student, who is the mediocre student. So it's difficult to understand further analysis. We are unable to understand further, you can, if you want to do another test preparation or you want to make another test, so you have to check the report of this test. So for the reporting for this test, if I want to show the performance of the class on the whiteboard, so it's difficult using this raw data. When I will organize and present on a graph, I can easily tell my student who is the best and how many students were in average part, how many students were outliers. So we have to interpret that data for the further tests. Okay, so let's start with the tally mark. So you can see 1 0, maybe the lowest person who got the marks 0, it's just 1. So you can draw one line. You can see here for Let me remove this. So there is just 1 0, so I'm going to draw the one tile tally, and there is 1 as a frequency. And then for 1, how many 1 we have to count? 1 2 3. So there are 3 lines or tallies, then frequency is 3, and up to 1 you can check. 2, how many 2's? 1 2, only 2 lines are there, and frequency is 2. For 3, 1 2 3 4, 4 lines, and the frequency is 4. I hope you got it and you can complete this. Thank you. Next, there is pie chart. Look at this picture. It's about the pie chart. Right, a pie chart has been drawn to show the promotion of farmers' tomato crop that were graded A, B, C, or rejected. So here we have some questions. We have to answer those questions by checking this pie chart. Pie chart is another representation way or representing the data, displaying the data, where you can use the sector angles to draw this. But here we are going to discuss what is the given in this question. Explain how you know that about 25% of the tomatoes were graded B. Look at this graded B, and you can use your protractor to check out the angle at graded B. You can use protractor in your exam. You're allowed to use that. It's a geometrical tool. So check out this angle. Let's say this is 90 degree. So 90 out of 360 degree, because in a circle we have 360 degree, times 100, you will get the 25%. That is it. So it was an explanation of the 25% of the graded B. Which grade was given to the largest number of tomatoes? So check out the, you already drawn the angle. This is the greatest angle here. So grade A is largest number of tomatoes. Sector angle of rejected tomatoes. So it is given 72. Find the total number of tomatoes represented in pie chart. It is interesting. You are not given the total number of tomatoes. You can easily find using the cross multiplication, and because you are given one part of the whole circle, which is the rejected part, which is 70 degree, 72 degree. So using cross multiplication for 72 degree, you have 480 number of rejected one, and you can find the total is 360 degree. So use cross multiplication to find the total tomatoes. So these are total tomatoes, whereas 480 were rejected. So we are given the rejected one, we are not given the total one, but you can use your mathematical technique or the mathematics, use of the mathematics will give you the number of missing one, which is unknown. This is the beauty of mathematics actually, which provides you the missing values using cross multiplication here. Okay, let's start with the next one. It is another part of the statistics representation. It is about the scatter diagrams. You can see in this diagram, it is also called the trending diagram. Trending diagram. Correlation actually is a relation of two quantities. I must say the relation of two people, relation of two quantities, like you have a business and your relation of sale and the number of products. If you have more money, you have to sell more products, more money. It's going up, positive. And here we are given two graphs. It's a positive increasing graph, it's decreasing graph. So this positive says a positive correlation, and negative says is negative relation. Positive means positive gradient, and negative means negative gradient. This line is going downwards, it has a negative gradient. You can see this is going downward with the passage of the time. For example, the petrol of your present in the car's tank will be decreases with the passage of time. So it's increasing with the passage of time. And let's suppose there is no correlation because there is no specific direction given. So there are three types we have: positive, negative, and no correlation. Sometimes we have no correlations, but there are some about the strong and weak correlations, but we are not going to discuss here because in Cambridge, in CIs, you will be asked to check the type of relation. So you can say this is positive, negative, or no correlation. And I will must say, if it is positive strong, then all of the dots, all of the crosses will be on the straight line. That's why this is called strong. And if the all the dots and crosses are out of the line, away from the line, it's weak. And if all of the dots on exactly on the line, then this is just like a solid correlation or perfect correlation. So we have a question here. We are given a table where shows a maximum and minimum midday temperature in degrees Celsius for each month in particular city in the northern hemisphere. So for the maximum minimum part of the temperature in January and up to so on whole year. So let me draw maximum and minimum one on the axis. I will not going to draw the number of months. I will, because I have to show the relation between the maximum and minimum quantities. That's why I'm going to take minimum along x-axis and maximum along y-axis. I will just mark the dots against these numbers 21 and 7. So if I'm not wrong, let me check out the 21 at maximum here. So for the 7 is below than on the x-axis and up to so on, you can check for 22 and it is at 9 and up to so on. This correlation is a positive correlation, and this is line of best fit. This is very important part. What is line of best fit? So I will must say it should be between the all the points, half the points below the line and half of the points will be the above of the line. Then it will be the line of best fit. Okay, maybe some points are on the line, but look at it must be from walk through or pass through all the points, and maximum points should be on the line. If you have maximum point on the line or even the first and last point on the line, it is not necessary to draw the line from the center from this. This line should be passing through all the dots. And there must be half below. If the points are not on the exactly line, then half will be the below the line, half will be above the line. And positive correlation, there are two types of correlation in this question. So there are some practice questions you can see. Yeah, these are the practice questions. You can take a screenshot and practice afterward. Okay, I have to put another class which is about the type of averages of. This is another topic, and we will inshallah ta'ala complete this topic in the next video. Thank you very much.